Do an internet search for cloud, and among the top hits you'll find are cloud computing and cloud storage. In this video, we're going to cover what this cloud is and what it has to do with computing and storage. Cloud is another name for a network of servers, data storage devices, and network switches. Clouds are hard at work, whether we're emailing, checking social media, surfing the web, or sharing pictures. Many bigger organizations, such as corporations and universities, have their own private cloud for computing, storage, and sharing. Public clouds provide similar services to organizations that don't want to invest in hardware and an IT department. Private, public, or hybrid, clouds are housed in large warehouse facilities called data centers, which are outfitted with thousands of servers. Servers are clamped in tall, standard-width metal racks. Wires lead in and out of each server to make the network connections. A warehouse that has thousands of servers working around the clock gets very hot. So cooling is a big concern in data center design. Regular air conditioning is inefficient in large data centers, since devices can function at moderately high temperatures. It also creates random recirculation of hot air. This has led to the hot aisle, cold aisle arrangement of racks. The front of the racks are placed facing each other across a cold aisle, and their backs face into a hot aisle. Computer room air conditioning units, or CRACs, compress the air and send it along vents inside a raised floor to the cold aisles to cool the devices. The hot air exhausts from the back of the devices and rises up through the hot aisle, where it is channeled back to the CRAC units for compression cooling. Since there is no clean separation between the hot and cold air, the circulation results in intermingling of the streams, leading to some inefficiency. This is now being addressed through containment strategies, where a physical barrier is installed, either around the cold aisle or the hot aisle. Direct liquid cooling is making inroads into the data center sector because liquid is a better conductor of heat than air. Liquid cooling is usually accomplished with pipes leading up to the devices or plates kept above them. Some data centers are also looking into direct contact cooling, where servers and devices are immersed in liquid or dielectric tanks. With all those devices running constantly, and with the amount of cooling they need, data centers tend to consume a lot of power. To lower costs, many data centers are located in rural areas with access to abundant and relatively cheap electricity. Lately, some of the large data center operators have built facilities in the cooler places of the world that have reliable power, such as Iceland, Sweden, and Finland. Some form of backup power, such as a generator and an uninterrupted power supply, or UPS, is also used to ensure no downtime due to unexpected power outages. Security breaches are a constant threat for individuals as well as organizations. Cloud security is aggressively enforced with layers of encryption, authentication, antivirus, and numerous firewalls. Aside from securing the network, data centers also have to physically secure their equipment and the facility as a whole. Data centers are typically housed in nondescript warehouse buildings located outside of cities, away from mechanical disturbances of airports and train tracks, seismic fault lines, and potentially hazardous sources such as chemical factories. Many are surrounded by tall fences and trees. Closed-circuit camera surveillance of the entire facility, both inside and out, is common practice. Aside from card readers, many sensitive locations also deploy biometric sensor technologies, such as retinal or fingerprint scans. Clients of shared data centers, called co-locations, frequently opt for cages surrounding their leased units. So that's what the cloud means in a physical sense. Here's how it relates to computing and storage. Broadly speaking, the cloud provides three kinds of services: software, platform, and infrastructure. Software as a service, or SaaS, refers to web-based software services often available on a subscription payment model. Well-known examples are web-based email, document sharing utilities, and finance software. This is the most visible layer of cloud computing and the one most of us are well familiar with. Platform as a service, or PaaS, is often used by software developers to build apps. Infrastructure as a service, or IaaS, involves leasing of servers, storage, or a network via a virtual environment to clients. This level of cloud computing is used by businesses looking for an easily scalable network without the hassle of maintaining a physical infrastructure. Virtualization is the key enabler technology behind IaaS. Vendors of virtualization provide an extensive software interface that lets clients customize a virtual network to suit their needs. This pick-and-choose methodology overlays an actual network, one that includes servers, storage, and switching devices, which the client never has to directly deal with. Virtualization has enabled many businesses to set up virtual networks without investing heavily in equipment and IT staff. To recap, a cloud is a network of servers, storage, and switching devices housed in a data center that needs to be cooled, secured, and powered with redundant power sources. Clouds are used to provide paid, free, or ad-based internet services to individuals and businesses. Thanks for watching. Remember to subscribe to the Tech Animate channel for more fun and informative videos like this one.